Hello friends, in this video we saw some new problems based on NMR spectroscopy. Now let's start to solve this. Then look toward that the first molecular formula C9H11Br. Okay, then one halogen atom is replaced by one hydrogen atom, and therefore when we find out the site of unsaturation, that is the 9 to the 18 plus 20 20, and here is a 12 hydrogen atom by 2, we will be get the 8 by 2, and of course there is the 4 site of unsaturation. Then the NMR data is given in this problem, that is the 2.5 delta, 2 hydrogen shows quintet. Okay, then 2 hydrogen shows triplet, 2 hydrogen shows triplet, and 5 hydrogen shows singlet, 7.2. So friend, on the basis of this data it clearly indicates that it is the mono substituted benzene ring. I just draw the structure of mono substituted benzene ring, and when benzene ring is mono substituted, that time what happened, then 5 hydrogen is satisfied, and the 4 site of unsaturation is also satisfied by this one. Now just count it, the 2 hydrogen shows quintet, so therefore there is a possibility that this is the possibility 2 2 4 4 plus 1, that is the quintet is shown by the central methyl group. Now 2 hydrogen atom shows triplet here, and same here 2 hydrogen atom shows triplet, then these hydrogen atom shows triplet. But friends, one of the 2 proton which are more d-shielded, and that d-shielded proton is must be joined to the electron withdrawing group, and therefore the possible structure from the given NMR data, that is the CH2 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 Br, and this CH2 having a delta value 3.4 because this 2 hydrogen atom joined to bromine atom. So friend, when you count the carbon atom 6 7 8 9, hydrogen atom is 11, and 1 bromine atom. In this way we have to solve this problem 1. Now we going to solve the second problem, that is the molecular formula C8H8O2. So friend, look toward, here is the given IR frequencies, and this is nothing but the aromatic stretching and carbon carbon double bond. Then 1700 is nothing but the carbonyl group. So friend, let's start to look toward the NMR data. Before find out these fragments from the NMR data, we just calculate site of unsaturation. 16 18 18 minus 8, that is the 10 by 2, and site of unsaturation is 5. So here is the 5 site of unsaturation. So friend, when we proceed toward the NMR data, 2 hydrogen shows singlet at 3.5, then 5 hydrogen shows singlet at 7.2. So this information is very useful because mono substituted benzene ring may be present here, not maybe, it is a confirmed one. So then look toward that, 2 hydrogen shows singlet, and 1 hydrogen shows singlet at 14, and it's clearly indicate that there is the carboxylic group, and this carboxylic group is joined to CH2, and this is the structure of proposed molecule. So friend, I hope you understand this, and for verification you just find out the site of unsaturation, then oxygen, then number of carbon atom, and of course this is the aromatic rings showing 7.2 delta value. Now the next problem based on NMR, that is the molecular formula C10H14, isn't it? And NMR data is given, I am already find out calculated here the site of unsaturation 4. Now friend, look toward 6 hydrogen atom shows doublet, 1 hydrogen atom shows multiplet, 2 hydrogen atom shows doublet and 5 singlet. Of course it is the aromatic ring. And which type of the aromatic ring? Of course that is the mono substituted aromatic ring. Then 6 hydrogen doublet, it means that 2 methyl group join to the single proton containing carbon is like this. This is the condition. Now 1 proton shows multiplex, of course that proton must be this. And 2 hydrogen shows doublet means this. Then count the number of carbon atom. Then this is a 6, 7, 8, 9, 10. And count the hydrogen atom, of course that is a 14. And you also check out whether the site of unsaturation is fulfilled or not. Then of course it is fulfilled because aromatic ring itself possesses the 4 site of unsaturation. So friend, we are going to solve the next problem, that is the C3H8O. And of course site of unsaturation is 0 here. IR frequency is 3300 per centimeter, which clearly indicates that there is the OH group. So 6 hydrogen shows doublet. There is again 2 possibilities. 1 hydrogen shows singlet and 1 hydrogen shows singlet. But both having the different condition. This is the highly de-shielded and this is the lower shielded than this one. Then therefore the possibility of the structure this is the possibility of structure. 1 hydrogen shows singlet, and there is, I think there must be correction in data is here. The correction is the 1 hydrogen shows multiplet or septate, and therefore we will get this structure for this given data. Now friends, we go toward the next molecular formula, C6H6O3. The data for this is site of unsaturation 4. I have already calculated here. Then UV data 220 and 250. It clearly indicates that pi to pi transition and N to pi star transition. Then IR data 1738. Almost it correlate with the ester. And 1480. It's nothing but the carbon-carbon double bond or conjugation may be present. So friend, look toward that. This is the 3 hydrogen atom showing the 3.81 and singlet. Of course, this frequency almost match with OCH3 group. Then this is very important one. 1 hydrogen shows doublet of doublet at 7.1. 1 hydrogen again shows doublet of doublet at 6.5 delta, and 1 hydrogen shows doublet of doublet at 7.6. So friend, here coupling constant can play a very important role. 3.5 coupling constant, 3.5 coupling constant, and site of unsaturation is 4. So there is a possibility of, on the basis of the coupling constant, there is the furan ring. Because furan having a coupling constant between this is near about 1.8 to 2. Then in between this hydrogen to this hydrogen, coupling constant near about 1, and in between these two hydrogen, coupling constant is 5. So friend, this 3 hydrogen is belong to the furan ring. Now the another remaining fragment, that is OCH3. OCH3 means what? And ester frequency, therefore it may be the C double bond OCH3. Now look toward the data. This is the 4 carbon atom, 4, 5 and 6. Then 3 oxygen atom and 6 carbon atom. Then the ester group should attach to this position of the furan ring. So friends, this is the structure, proposed structure from the given molecular formula. Now in this video, we will solve near about the 4 to 5 problems which are based on NMR spectroscopy, and remaining problem I will be sent to you on Google Classroom in the form of PDF notes. So friend, take a notes in your notebook, and you have any doubt, ask me. In our next video I will send you the coupling constant related to the different molecules. Thank you very much. So friend, as we know that coupling constant is denoted by J, capital J, and coupling constant is nothing but the difference between two peaks or the two protons showing the values, that's known as coupling constant, because each proton is coupled with the another proton with the proper distance, and that values I will explain here by this chart. Now look toward this. When two hydrogen atoms, this hydrogen atom is known as the geminal hydrogen atom. When these two hydrogen atom is joined to the same carbon atom having a coupling constant 12 to 15 hertz. Coupling constant is generally expressed in unit hertz. Now here is a vicinal proton, and here is the two carbon atoms joined with the single bond, and two hydrogen atom is attached to this having a coupling constant is 7 hertz. Now look toward this. There is the long range coupling constant, and that is almost less than 1, near about 0 in case of the single bond. Now look toward, it is a cyclic compound, and two proton are coupled with each other in between 5 to 10 hertz. Now it is a 4-membered ring, and both the protons are cis. If they are cis, there is a 4 to 12, and if they are trans, there is a 2 to 10 hertz of the coupling constant. Then friend, this is the CH, and this is the hydrogen atom attached to the oxygen, not to the carbon, but it also shows the couple with each other, and therefore that coupling constant is 4 to 10. Now look toward this example. I hope you are visible. This is visible for you. C double bond CH, C double bond OH. Then this hydrogen couple with this hydrogen and having a coupling constant near about 5 to 8 hertz. Now friends, when we go toward the double bond or saturated compounds, C double bond C, and here is a trans hydrogen atom related to double bond, there is a very high coupling constant is observed in between two hydrogen atom, that is from 12 to 18 hertz, isn't it? And when double bond, when alkene group having a geminal hydrogen atom, the coupling constant is very low, that is a 0 to 2 hertz. And in case of alkene, the two proton means vicinal alkene, that time 10 to 12 hertz coupling constant is observed. In case of this, there is a 1 to 2 coupling constant is observed. Now friends, it's very important for your study, that is the acetylene group, means triple bond. In between these two hydrogen, 2 to 3 coupling constant is observed. Now look toward the benzene ring. Here is the ortho proton 6 to 10. Coupling constant is always observed in between 6 to 10 in case of the aromatic ring. Now this is the ortho coupling. This is the meta coupling 1 to 3 hertz. And in case of the para coupling, that is the 0 to 1 hertz. Now friends, this is the pyridine molecule. The coupling constant is observed in case of ortho proton, that is a 5 to 6 in this way, and when proton is near to nitrogen and proton is goes away from the nitrogen, the coupling constant is 7 to 9, the ortho proton, and away from the nitrogen. Then meta coupling in this case 1 to 2 hertz. Now in case of furan, we just solve the numerical based on furan 1.8. This is the 3.6, and from the long range coupling 0 to 1. In case of thiophene, 5.4 in between these two protons and 4 hertz in between these two protons, and the meta coupling or 1,3 coupling is 1.5 hertz. In case of the pyrrole, in between two hydrogen atom, look toward that, the coupling constant is 2.3. And here is the 2.3 again, and in between these two hydrogen the coupling constant is 3.4. So friend, for the simplification, for the study of spectroscopy, for the study of the next incoming exam like NET, SET, GATE, to remember the values of coupling constant is very useful. After watching the video, you have to take screenshot. Thank you very much. Hello friends, in our previous video, some students aren't able to see the molecular formula and solve problem clearly, and that's why in this video I just take the represented numericals in this way. You just look toward, this is the first example we have solved in the previous video, in which having a molecular formula C9H11Br. Now look toward the second example we have solved in that video, that is C8H8O2, isn't it, having a structure of this acid. Now of course it is a benzoic acid. Now in third example, we have solved the example of molecular formula C10H14, having the molecular formula this one. First we have find out the fragmentation. Now in fourth example we have solved this example C3H8O, and in last example we have solved the having a molecular formula C6H6O3, and structure is this of furan. I hope you understand these examples, and if you want any explanation, you just watch the NMR video 8. Thank you very much.